Good morning. In this session, we are going to see about a mass transfer from the subject heat and mass transfer. What is mass transfer? In generally, the heat transfer is accompanied with mass transfer, for example, evaporation. In convective heat transfer, a bulk fluid motion occurs on a macroscopic level, but the mass transfer requires the presence of two regions at a different chemical compositions. In this, the mass transfer refers to the movement of chemical species from a higher concentration region to lower concentration region in the presence of medium. The diffusion process is strongly influenced by the collision of molecules. The mass transfer also occurs in the liquid and solid as well as in gases. The rate of diffusion depends strongly on the temperature, since the temperature is measured of the average velocity of the glass molecule. The diffusion of carbon into iron during case hardening and the doping of semiconductors are example of solid to solid diffusion process. Another factor that influences the diffusion process is the molecular spacing. Here the larger the spacing, the higher the diffusion rate. That is why the diffusion rate of gases in which the higher than the liquid and solids. If the driving for the heat transfer is temperature difference, the driving force of mass transfer is concentration difference. Mass is transferred by conduction, called diffusion and convection only. The rate of mass diffusion of the chemical species A is stationary medium of the direction S, we can see in this figure, is proportional to the concentration gradient in the direction and expresses Ficky's law of diffusion. The DAB, that is the diffusion coefficient of the species in the mixture. Mass diffusion is equal to minus DAB, that is diffusion coefficient into A into delta A by dx. That is Q is equal to minus Ka into dt by dx. The mass transfer coefficient is for a heat convection, that is a heat transfer coefficient into temperature and temperature difference. For a mass convection, the mass transfer coefficient into concentration difference. Mass convection. The mass convection is a mass transfer mechanism between a surface and a moving fluid that involves both diffusion and bulk fusion motion. The fluid motion also enhances the mass transfer considerably by removing the high concentration fluid near the surface and replacing it by a lower concentration fluid. That is a mass diffusion. Mass basis, it is a partial density and total density of the mixture. And the mass concentration can also be expressed in dimensionless from in terms of mass fraction, that is a mass fraction of species is equal to rho I by rho. Mass diffusion, the mole basis in which the amount of matter in kilomole per unit volume. The molar concentration of mixture at a location is equal to the sum of molar concentration of its constituency at that location. The molar concentration can also be expressed in dimensionless form in terms of molar fraction as Y. The mass and molar number of the substance are related to each other, where M is a molar mass of the substance. This is expressed by this, since the mass 1 kilomole of the substance is mole kilogram, and thus the mole of n kilomole is the mole number mass into kilogram. The mass diffusion, therefore the mass and molar concentration are related to by each other, that is U is equal to rho by m1, and where m is a molar mass of the mixture, which can be determined as small m, that is mass by molar number. The mass and molar fraction of the species, that is I of mixture, is related to each other. W is equal to Y into molar mi by m. It is a mixture in the both species A and B. It is a mixture A plus B, and the molar mass basis and mole basis and relation between them are derived. Mass diffusion. The primary driving mechanism of mass diffusion in the concentration gradient and the mass diffusion due to concentration gradient is known as ordinary diffusion. However, the diffusion may also be caused by other effects. The temperature gradient in a medium can cause thermal diffusion, and pressure gradient may result in a pressure diffusion. Both of these effects are usually negligible, however, unless the gradients are very large. It is a problem. The composition of a dry standard atmosphere, in which on the molar basis 78.1% of nitrogen and 0.9% of oxygen and 1.0% of argon and other constituency. Treating other constituencies argon determine the mass fraction of the constituents of air. Solution: the molar fraction is given as a mass fraction. Molar fraction is given. Find the mass fraction. Here the mass fraction is equal to 0.754. The oxygen mass fraction is 0.231 from the formula. Determine the mole fraction of the water vapor at the surface of lake whose temperature is 15 degrees Celsius and compare it in a molar fraction of water in lake. Take the atmospheric pressure lake level is 92 kilopascal. It is a diagram represented. Solution: the air at a surface and the lake is saturated, therefore the partial pressure of water vapor in air at a lake surface is simply the saturation pressure. The pressure is 1.705 kilopascal and the mole fraction of water vapor in air is surface, and the Y is equal to P by P is equal to 0.185. Thank you.